I want to find the limit as x approaches 1 from the right of root 2x times x minus 1 over the absolute value of x minus 1. So the absolute value of x minus 1, the graph for it is basically absolute value of x, but shifted over 1 unit. So it's something like that. To the right, you see the function x minus 1, and to the left is the function negative quantity x minus 1. So we can rewrite the absolute value of x minus 1 as just negative quantity x minus 1 if x is less than 1, and x minus 1 if x is greater than or equal to 1. Here, because we're looking at 1 from the right, we want to be looking at this graph right here, which is this one, so to the right of 1. So we're going to make a substitution. So instead of absolute value x minus 1, we're just going to leave it as x minus 1. So let's rewrite the limit now. So it's x minus 1, and then the bottom is also going to be x minus 1. Those are going to cancel. And when I plug in x equals 1, I get my limit to be 2. Now, what if we looked at the limit from the left? So what if instead I looked at 1 from the left of root 2x times x minus 1 over absolute value x minus 1? Well, I know from the left, I'll be looking at this graph right here. Right, so I'll be looking at this part of the graph. So I can replace the absolute value of x minus 1 with a negative quantity x minus 1. So the x minus 1s are going to cancel, and I'm left with really the same limit as this one here, except I have a negative at the bottom. So this negative will come out, and the limit will be root 2. So that's the same thing as this one right here. These two are the same, but I just have the negative in front. And so the limit is just negative root 2. Alright, next we're going to be looking at the floor function, or the greatest integer function. So let's say we have limit as theta approaches 3 from the right of floor theta over theta. So let's just make sure we understand what this means. So this greatest integer function is basically we're looking for an integer, the greatest integer that is less than or equal to theta. So for example, if I look at 1.5, I want the greatest integer that is less than or equal to 1.5, and that is just 1. What if we have 2.7? That will just be 2. Or if we have 0.3, that will be 0. So for any positive values, the greatest integer function will just be the integer part. But now if we look at the negative values, let's say we have negative 0.5, the biggest integer that is less than or equal to negative 0.5 will just be negative 1. Or if we do negative 1.3, that's going to be negative 2. So it's really this value minus 1 for when it's negative. Okay, so let's look at this now. So here I'm looking at 3 from the right. So what happens when we're looking at 3 from the right? Well, if we were to graph this, if I'm looking at values, so let's make a table here. When theta is between 0 and 1, not including 1, so it could be like 0 0.5, 0 0.3, 0 0.1, the floor of it is just going to be 0. If it's between 1 and 2, it's just going to be 1. Between 2 and 3, it's going to be 2. So it's always a smaller bound here. So it's a smaller integer, right? So we're even looking at the lower bound there. So if it's between 3 and 4, you want the greatest integer that's smaller than or equal to theta. So in this interval, it's going to be 3. So if we were to graph this, it would look something like this. So it looks like a step function. And of course, you can repeat it over there, but we don't really care about that. So if I were to break this limit up now, so if I were to say limit as theta approaches 3 from the right of the floor function of theta divided by limit, let's see, theta approaches 3 from the right of theta. So the floor function of theta as theta approaches 3, but we'll be looking at this part of the graph. This is when theta is 3, like the x value. So approaching from the right, it's going to approach, sorry, that's not right. From the right, let me redraw this. So we have 1, 2, and 3. So if I'm approaching it from the right, I'm coming over here from the right. That value is going to be 3. And then theta, as theta approaches 3 from the right, that's also 3. So my limit is just going to be 1. Now instead, let's look at theta approaching 3 from the left. I can break this limit up like I did the one on top as just a floor of theta over theta. And now I go to my graph and I see I'm approaching 3 from the left, so that's going to be over here. And that approaches 2. So the y value here is 2. So this is just going to be 2. And as theta approaches 3 from the left, theta approaches 3 as well. So in this case, the left-hand limit is 2/3 and the right-hand limit is 1. Now let's look at another greatest integer function. Let's say I have limit as t approaches 4 from the right of t minus root, or greatest integer function t. So I can draw the graph. It's probably the easiest. If I have the graph, then it's really easy. So we know between 0 and 1, it's going to be between 0 and, it's going to be 0. Then we're going to jump to 1, then 2, 3, then 4. So if I'm approaching, so here I'm going to break this up into 2 pieces. So right now I'm just looking at this. So this limit. So if I'm approaching 4 from the right, that's going to be over here. And that limit is going to be 4. So this part is 4. Now I could just plug in 4 for t, which will be 4. So I get 4 minus 4 is 0. So my limit as t approaches 4 from the right will be 0. Next, if we look at it 4 from the left, we know that for t, this one is still going to be 4. Okay, but what about the floor function at t? So it's 4 from the left means we're approaching it from over here, and that y value is 3. So this is 3. So 4 minus 3 is going to be 1. So my limit there is 1.